Okay, in this tutorial we will be covering the Functools module. This is a module that is built into Python, mainly for higher order functions. We will go through many of these functions, many are function decorators, and we will go through some concrete examples on the most common use cases for this module. Okay, the first function that we'll be covering is the reduce function. So the reduce function, basically it's also known as an accumulator. So what it does is it loops through everything inside of an iterable and then reduces it to a single value. Okay, switching to the editor here, the first thing we need to do is import reduce. And we'll just start off with a list of numbers. And I'll create a new variable called total. And the first item that first argument is going to be a function, so we'll use a lambda function here. And our return value will be x plus y. And then we have to pass in our list as the second argument. Okay, so we'll go ahead and run that. And we see our total is 10. So basically this is just much shorter and more concise than setting like an initial total value and then doing a for loop and then adding each single time. So this just is a shortcut, handy way of doing that. So inside of here, we notice we have a lambda function. We can also use any sort of named function. I'm going to go ahead and do that next. We'll just call add it. We'll take in an x and y. And then we'll do the same thing as we did before. And then so we're just passing our function name only as the second argument in our list. And print that out again. And we get the same exact total as we did before. Okay, so there's a couple things to keep in mind with this. Let's just say we're somehow generating this list dynamically, and then there's a chance that the list could be empty. That creates a real problem if you don't use an initial value. So I'll go ahead and try that. And as my sequence, I'm just passing in a list with nothing in it. So I'm going to go ahead and save and run it. And notice that we get this type error, so empty iterable with no initial value. So if that is the case and we know that it's a list of numbers, we can just set an initial value to 0, and then we should get it should run just fine, just giving our total of 0. And it looks like I made a mistake here. Pass initial value in, but no iterable. So let's go ahead and fix that, and then we see our total is 0. There's one more case I wanted to cover with these examples. You can use it to find a max value. It's probably not the best way because Python already has that, but we'll just do that for illustration purposes anyway. So do the same thing as before, lambda function. So return x if x is greater than y. Else we'll return y. So it should give us the max value. And we see 4 is our max value. Okay, so we can also do this with a list of strings. So I'll just create a new file here. And then import reduce. So what we're going to do here is just concatenate everything. So when we add two letters together, it's just in Python it'll be string concatenation. So go ahead and create a result variable. And then, so we have a single string value of A, B, C, D, E, F, and that's just everything in this list concatenated together. Now we can also iterate through a single string, so I'll just create a string value. Okay, so this is different from above where this is basically a list of characters, and now we have a single string. Okay, so we basically have two of the exact same thing. So what it's going, so since a string can be an iterable, it's going to iterate through each one of these characters the same way as if it was inside of a list. That is why we're getting the exact same result as we did with both of these examples. So that's something to keep in mind whether you have lists or strings when working with strings. Okay, so the next thing we're going to cover is a list of dictionaries. And I'm going to go ahead and paste a list of order items. So each item is a dictionary. It's got an ID, a name, an amount, and a quantity. So let's just say all we want to get is the total amounts of all of these. So we want to return X, which is the previous value, plus Y, which is the amount. And then our iterable is order items. So with this, we're going to run into an error. I'll just show the error and then I'll go ahead and fix it. So the problem is that since we have a dictionary and it's not just a single primitive type, it has no way to know what data type and what to infer as the initial value. So it's thinking that the very first value is trying to add a float to a dictionary. So the way we fix this is we have to set an initial value of 0 since we know it's numeric. And then that will fix the problem. Otherwise, it just has no way of just looking at this and say, well, what are we adding to on this? And then we have an amount of 357. Okay, so moving on to the caching functions. These are all going to be decorators. The first method we'll cover is LRU cache. What this will do is it will save the result of a function every time you call it with every single distinct arguments that are passed into it. At LRU, that is least recently used. And what that does here inside this Wikipedia article, here's a visual demonstration of it. So we basically have a cache with a capacity of 4 items, and then we just come in here, something gets filled in with each step. And then by the time we get to step 5 with an index of 4, since this example is 0 based, so something has to be dropped. So A was the last one that was used, or not the most recent, so that one gets dropped. And then here comes D5. D is already here, so that one becomes more recent than any of these others. And then the way that this algorithm works is it has to maintain a fixed capacity. Okay, so in this file we have a Fibonacci method. So the way Fibonacci numbers work, if you've ever worked with them in the past, because of this recursion, even if you passed in like a modest number like 40 or 50, it's going to take a considerable time to run. There's going to be a big lag because of all the recursion. So let's just start off by actually running this. And I'll just give it a value of 35. So even with 35, there should be a noticeable lag here. Okay, so we got our result back. It's 9.9,227,000 something, and you notice that it took at least a couple seconds in order to run this. So what's going on here is we're basically calling the same function with passing in the same numbers like all the way up and down. So so we can fix the performance of this quite a bit using a cache. So let's go ahead and import LRU cache. Now the way this gets implemented, we use a decorator with the at function. So this is going to modify how our function works. And we'll go ahead and set a max size of 128. And then actually, if you'll notice that 128 is actually the default. And then since we're looking at the document, the actual code here, what I bring up is this typed character. So like I said, every time you use this function, so if you call it with passing in an argument of 3, and it's going to save the result of that function is what's being cached. But if you have this typed set to true, then this is going to use up 1 slot in the cache, and so is this. So even though we have a 3.0, which is a float, and 3, which is an integer, they technically are equal, but these are going to be treated as distinct calls, so they're each going to take up 1 slot in that cache. So that's just something to keep in mind if you require strong typing. Okay, so I'm going to go ahead and save this and then rerun it, and we should notice a considerable speed difference. See this? It just returned the result in a split second. So yeah, it's a huge difference if you have since we have a lot of recursion inside this function. And then one other thing I wanted to point out here was this is basically using a wrapper around the function. Then if we come down here to this cache wrapper, we notice that there's a couple of extra things being added to it. So we're getting this method called cache info and cache clear. And the cache inflow is our cache statistics. So this is very useful. We'll go ahead and use it as an example here. Print. So then we want the name of our function and the method tied to that. So cache info. Let's go ahead and run this again. Okay, so notice we passed in a value of 35, but since this does a lot of recursion, so we see that we have a number of hits and misses. So this means we have 36 items in the cache because it ran 36 times, or 36 distinct times. So basically the 36 means that the actual what's inside the function actually ran 36 times, and then a hit means the cached value was used. So basically this repeated a number of times where the code did not have to be rerun. It just saved the result and then just gave us the result back to us. And then since 36 is below our max size of 128, our cache has actually remained below the full capacity. Okay, so the next decorator is actually just called cache, and what this is this is just a shorthand for, this is actually using LRU cache under the hood. So if we go inside the implementation, it's basically using LRU cache with a max size of none. So your cache is going to be unbounded, so there's no limit to, at least theoretically, how big the cache can get. So that's something to keep in mind if you use the shorter syntax. So all we have to do is change that and remove any arguments, and then we should get the same result here. And notice everything is the same except for max size in our case. Okay, and the final caching function that we'll be covering here is the cached property, which can be used for a method inside of a class. So I'll just go ahead and create a new file. I'll go ahead and just create a class called customer. And we'll take in an argument called orders. And this will be a list. So I'll just set self, So self underscore orders will be equal to orders, and then we'll create a new property. And we'll call this recent orders. Okay, so what I'm going to do here is create a list called orders. This is just going to give us some dummy data to use for when we call the recent orders. Okay, this is similar to the example that we were working with earlier. I made a couple differences to it just to basically had this order ID, and we're going to assume that the highest number is the most recent. What I'm going to do here is create a variable called orders. And we're going to call the sorted function. This is a built-in Python function to help us sort. So we need to pass in our iterable, which is what we have, self underscore orders. And then we need to set a key. And we'll be using a lambda function here. And so what we want here is this order ID for every one of these dictionary items. And then since the highest number is considered the most recent, we have to pass in the reverse argument so it knows to sort them in descending order. And we'll just return the last 3 orders. Okay, so in order to use this, let's create a new customer. And when we initialize customer, we need a list of orders. So that is going to be this. And then, so we'll go ahead and print that method that we created, that property method. And that was recent orders. So if this is correct, and if we go ahead and run that, we get a list back with our last 3 items. So this is an order ID of 7, 6, and then 5. However, if we run this multiple times, so in the real world, what happens a lot is if you call this is making a call to another service. It could be a database query or something like that, and then you have 2 different places in the application where you're accessing this property. What we don't want to be doing is just making multiple queries just for the exact same data. So what we could do is cache this. Actually got the wrong import here. And then we'll convert this to a cache property. So if we were to use this somewhere else in the application, then this will load from the cache. Since it's the second time, it'll save the this return value right here. So here we just printed it out twice, but that's really all you need to use cache property inside of a class. Okay, in this section we'll be covering the wraps function. What this does is it allows you to wrap different functions. So basically with a wrapper you can run pre-processing, run the function, then post-processing. This does several things for you. For example, you can just encapsulate code that anytime this internal code changes, you only have to change how everything within the wrapper. You don't have to change anything else within the code base. Another benefit is something that handles retries, which is going to be our second example, where basically we're using the requests module to make external API HTTP requests, and then if we get back any sort of an error, we can set a delay and then retry as long as we're under the retry limit that we had set out. Okay, so now we can go ahead and import wraps from Functools. And we'll do a really simple example. We'll just call this function say hello. We'll take name in it as an argument. Okay, so this function is very concise and straightforward. So I'm going to go ahead and create a wrapper for this. We'll just call it my decorator. So the function is what we're going to be passing in as the argument. Now we need to use our @wraps decorator. So we're going to create a new function inside of the decorator function. So we're going to take in all arguments and keyword arguments. And actually need a double asterisk here. So for pre and post processing, what we're just going to use print statements to simulate that. So we'll just print before executing function. So right here, we want to actually call our original function that got passed into here. This is going to actually run the contents of the function we originally set up. And then we want to just carry forward any arguments that were passed in. So this is going to be our post-processing. So we'll just print after executing function. And then so what we have to do to our original function, so we need to add the decorator. So at my decorator, then we save and run this. Okay, it looks like we got an error. So you see none type object is not callable. Oh, and the problem is that we need to return this wrapper function. So return wrapper. So now this should actually work. And so we see our pre-processing, the output of our actual function, then our post-processing. So that is basically how this all works. One thing to keep in mind here also is by using this wrapper, we basically have access to the original doc string and the original name of the function. So let's just go ahead and add a doc string. So say hello. Say name as a string. And we use the double under name, and then so we're printing out these double under methods for our target function here. So since we used the wraps function here, we should actually get the same function's name and doc. So go ahead and save that and run it. So here's our doc string right here, and then here's the name of our function. So if I were to comment this out and run this again, so we basically got none as our doc string, and then the wrapper function is what's actually tied to these double under methods. So by including wraps, this actually preserves all the double under data regarding our original function. Okay, so in this next example, we're going to use a more realistic example. We're going to be using requests to make an API request. So request is one of the most popular modules in Python, one of the most popular libraries. So if you need, you can install just with pip install requests. And then for testing this out, we're going to be using HTTP bin. This is just a website that you can send a request to and it'll post data back to you. So it's just an easy way of simulating requests. So if I were to go to this URL, for example, it's going to give me some JSON data back. It's mostly the same data that I originally passed in, plus some headers information that was actually in the original request. So if I were to go ahead and run this as is, notice that everything here is just a synchronous external request. There's no retries or anything like that. We're just using the library pretty much as is. Okay, and just like in the browser, basically you got this whole JSON blob back as a result. So the next thing we're going to do is use wraps from Functools. What that's going to do, we can set up a means of retrying and then setting some sort of a delay between the retries. This what happens a lot with requests, especially external HTTP requests, is you can have too many requests at the same time and they get throttled. So retrying them after some sort of a delay when there's less traffic or fewer requests being made at the same time, then it works the second or third time around. This is just putting in a more robust way of managing having to make requests and getting data back. Okay, so to implement our delay, we're going to import the time module. And so obviously we need to import reps. Okay, I'm going to create some space here. So we'll call our new function retry requests. And so we'll take in a couple arguments. The first one will be max retries. Give it a default of 3, and then we'll set a delay with also a default of 3. And for now, I'll just put a to-do placeholder here. So we'll go ahead and create a second function called fetch data. So here we need to take in two different sets of params. So we need a URL and params. And we'll give that a default value of none. And we'll say return. So we're running basically just executing this request.get the same way we're doing down here, except we're just parameterizing these items. So we'll just go ahead and change this down here. We'll just say so we'll just pass in our HTTP bin URL and then a set of params. And so since we're going to be using a decorator to handle this, we want to actually check and make sure we have the response. So that's how we're going to be setting this all up. So up here, we need to go ahead and implement this. So create a decorator function. So the function is actually what's being passed in here. You have to remember to return the decorator. Okay, so in here we're going basically 3 layers deep, because what we're doing here is we have to manage 2 sets of params. We have to manage these max retries, and then we also have to manage this delay along with the original params, which is the URL and the get parameters from request. This is more, if we went with something less flexible, we might be able to get rid of one of these layers, but in theory, we should be able to set up sort of any other function, whether it's get, post, whatever, and then be able to wrap this using the same code. So this is actually the more flexible way. So what's going to happen is if this runs and fails, it'll retry up to 3 times, adding a delay of 3 seconds between each one. So the next thing we have to do is actually implement handling everything inside of our wrapper here. So I'm going to go ahead and set up a for loop. Call this for attempt in range. So we're gonna basically up until our number of max retries. So I'll just set up a try catch block here. And what we need to do is carry forward all of the arguments. And this set of arguments is going to be actually these right here. So let's add our accept block. So request.request exception. So what we want to do here is check the number of retries that we had. So we'll set an if block. So if attempt is less than max retries -1. Let's just go ahead and set up a print statement. Source mark request failed with error. And what we're basically just converting this error statement to a string, so this should give us the actual error message if this exception gets hit. And we'll just print out that we're going to be retrying this. So we'll say time.sleep. So this is what's actually putting in the delay. And we'll say max retries reached. So we'll just go ahead and re-raise the exception. Since there's just no more retries left, we just will throw the exception. And then we have to remember that if we get all the way through this loop and then it still hasn't worked, we need to return none. Okay, so when we actually make the API call, we'll just set a new print statement saying that we're making the recall and then what response code we got back. So if we got if we get a 200 response back, we know it went through. So a 200 is a status code. That means the attempt was successful. If we, on the other hand, if we get like a 400 or 500 level response code, that's how we know it failed. So from the response, we should be able to get the original URL. So we'll just print that out here. And then we'll print out the status code also. Okay, so now if we, like I said, if we get the status code of 200, we're just returning the response, and then this will be the end of our for loop. We should not hit this line of code down here, which is why if we check for the response, if this is not none, then we know we actually got this whole response. Next one we'll be checking for is response of 429. The way that we can implement it through HTTP bin, we can just come down here to status codes. So if we say get/status code, so let's just try it in here. I'll just copy that. Say status/429. So you see we got HTTP error 429. So yeah, this actually worked as expected. So we'll go ahead and save this as a way of testing our error URL. So let's go back to the code, and then we'll just say, we'll just create a new variable. And we'll just pass this in order to basically test this whole thing out. So what we're going to put in here, we'll just put a new print statement, or say rate limited. So 429 usually means you hit some sort of a rate limit. So say waiting and retrying. And then put in our delay. And we'll just go ahead and do one more block. We'll just say less than 600 to catch anything that's not a 200, but still less than 600. So if it's 500 something, it's usually an internal server error. We'll say server error. And then if nothing catches any of this, we'll just raise an exception. So what requests does, when they return a response, so they have this raise for status method. So if you do not get a 200 back, it'll automatically raise an exception. So we'll just go ahead and since it's returning a code we're not anticipating, we'll just go ahead and raise an exception here. Okay, looks like we've got an indenting problem here. Let's go ahead and fix these. Okay, so if this was all put in correctly, there's a link to the source code in the description also, if this was a little bit hard to follow, but let's go ahead and retry this. So this should work on the first try because we're still passing in the valid URL. So this should return a 200 response back and then print our result. So let's go ahead and run that one first. Okay, so we got the same thing back as before. Actually, you know what? I forgot to put in the wrapper here. So we need to add our decorator. So retry requests. We'll just say 2 max retries and then a delay. We'll set that to 2 also. And we'll try rerunning this again. Okay, so that still went through as expected. Let's go ahead and switch to the error URL. So I'm going to go ahead and use that. And since this is not going to return a 200 code, this should actually run twice with a short delay and then ultimately return nothing. Okay, so our first one went through, and then here's our second one, no response received. So this is what we expected. The first one failed, and it tried it again after a 2-second delay. So, I mean, this is just an approach that you can use in the real world. So say like you have a request that's intermittently, sometimes it doesn't make it all the way through. And then you can also set some sort of exponential back off here, so you can have some sort of multiplier where based on the attempt, whether you're on attempt number, depending on how many of these you have, just multiply these together. So the first time it would be a 3-second delay. The second time, 3 times 3 could be 9, for example. So you can also do it that way. But yeah, this is just a simple way to get this started here. Actually, there's one more thing I wanted to cover. Like I said earlier, since we're wrapping this, we should be able to preserve the name and doc string. So let's go ahead and do that. Say double under name and doc. Okay, we got fetch data and none. We don't have a doc string inside of fetch data, so we can just go ahead and add that. Okay, let's go ahead and rerun this. And then we have our original values here. Let's go ahead and then just to test to make sure this works as we expected, I'm going to comment out this the wraps decorator here. Let's rerun this again. Okay, so it did that same thing as before, wrapper and none. So by including this, we actually, even though we're multiple layers deep, we still preserve the whole doc string and name of the originally targeted function. So, okay, so the next function that we'll be covering is partial. So what we just implemented before using wraps, what that's using under the hood is partial. So partial allows you to create functions from other functions where you can freeze some of the parameters, one or more of the parameters in the original function. So to illustrate how this works, we'll use a doubling function to do this. So we'll just go ahead and import partial. And I'm just going to create a simple function here called multiply. Okay, so from that, we're just multiplying two values together, whatever arguments that are passed in are going to be multiplied. So if we want a function derived from this that only just doubles another function, just doubles a certain value, we can do that using partial. So I'll create a new variable called double it. So the first thing we need to pass in is a function that we're going to be using partial on, and then a value. So what this does is it basically freezes this x value as 2. So no matter what number we pass in, it's going to multiply it by 2. So even though we declare this as a variable, this is going to be a type of a function. So let's go ahead and just print the type. And then let's just say we want to double the number 5. We can do that. So print. And then just pass in a single argument of 5 because x is frozen. Let's go ahead and run this. Okay, so we have a class of functools of partial. So it's actually a wrapped function, and then our value, we got our answer here, which is 10. And that's pretty much all partial does. Now obviously there's some sophisticated ways to implement this. Like for example, this was passing in these constants. So if we were to look at these, this is why that metadata was able to be preserved when we were wrapping functions. It's because of this. Okay, so the final section will be single dispatch functions. What this allows you to do is, depending on the data type of the first argument, we can have multiple function implementations. So in this example here, we have a JSON converter. So we're just simply converting it to a JSON string, and then this will run just fine as is. However, if I were to create a new variable, let's make it a set. Okay, so we created a set here. We'll just go ahead and run this. Okay, so we get this error here. Object of type set is not JSON serializable. So the way JSON works is that things like dictionaries, lists, and strings, numbers, those are all serializable. But since there's no type of set supported in JSON, so we have to do something to fix this problem if we want to convert this to JSON. So one thing we can do, we can use single dispatch to fix this problem. So let's go ahead and import it. So we have to add single dispatch as a decorator to our, this is now going to be our default function. So we'll create a new function. So we need to add original function as a decorator, and then we need to register it. So we're registering it with a type of set. So anything that is has a set as this data argument will actually be executed by this function, and then anything that's not a set will fall back to the default. Since the default function's handling is already named, we don't need to name our new function, so we can just use an underscore as a placeholder. So what we can do here is just put in a special implementation for sets. So we'll just convert it to a list. Okay, so now that we have that put in, we go ahead and rerun this. Okay, and then so a serialized is basically a list of 1, 2, 3, which before it was a set. So Of course, we could have just come in here to the original function and just check the data type and then, use like an if condition. Where you're going to run into this quite a bit is in libraries especially. So libraries have these really generic functions that can just take multiple data types as arguments, and then the difference between the original function and these other functions that extend it, they can become quite extensive, the whole differences between them. So that's why you see them a lot more in libraries than you do regular applications. But when you're going through a library, it's always good to understand how all this is working. And inside of class methods, there's also a single dispatch method decorator. We'll just run through a quick example of how that works. So I'll go ahead and create a new file for that. So for class methods, the decorator is actually called single dispatch method, which I'll go ahead and import. And we'll just create a simple class called math. And let's just go ahead and take in a value. So let's go ahead and create a new method called add. And then we'll return value plus item. Okay, so this will work just fine if we set initial value as a number and then every item was also a number. Let's say we wanted to add strings and add lists. So we can use a single dispatch method to create different methods for each data type. So we just need to add the decorator. And so we need to register any subsequent methods that extend it. So we'll say string is our data type. And we just need an underscore for the method name. We don't need a name. So let's say example, if this is a string, let's just return an F string. And for the example, we'll just create one more. We'll just take in a list. Okay, so for the list, we'll just convert value into a list of one thing and then add another thing to the list. This is self-explanatory, pretty self-explanatory, so we'll just go through a very quick implementation here. Okay, so we have our three different data types. We're just testing these three items out, and we'll go ahead and run it. Okay, so the first item we get basically just an integer value of 10, and then we have a string, comma, space, lucky, and then we have a new list of 7, 9, and 11, just as how they're implemented right here. So this is how you can use single dispatch method to use this whole single dispatch for multiple implementations of the same name function depending on the data type of the argument.